Okay, this is gas lecture number 5, and we're going to continue with Dalton's law with problem number 8. So one of the things when we look at problem number 8 is we notice that it does not say collecting over water or water displacement. Therefore, you won't need to use the blue sheet, and we won't be dealing with the partial pressure of water vapor. But you can have any number of gases. I mean, just think of all the gases that are around us all the time. So in this particular example, trapped in a container are helium, oxygen, and methane. The total pressure will equal the partial pressure of each one of those. Now, again, it's very important that you follow the exact format here. You're going to lose points if you don't put, if you write helium, write the word helium. That doesn't cut it. The formula of these. And again, at the beginning of our gas law units, we reviewed those gases which I would expect you to know or to be able to figure out. And certainly these three are amongst there. And they won't necessarily say O2. They'll say oxygen gas, and then you have to know that it's diatomic. So this becomes relatively simple plug in and solve for the unknown after that. So the total pressure was 96.4, and again, perfectly okay to leave the units out in the setup of these things. I prefer that, actually, with this, just to give you an exposure to, many of your college profs will let you do this on the mathematical step, and just make sure you have the units at the very end. So you can see we need these three things to add up to be 96.4, so we're going to be subtracting. And this is really all about place value because we're adding and subtracting. So whatever device we used to measure the pressure was accurate one place to the right, and you can't really change that. So when we're adding and subtracting, you'll end up with one place to the right. So you just take 96.4 minus 13.5, hit the equal key, minus 29.3, hit the equal key, and you will get an answer of 53.6 kPa. And again, don't forget that part. If you just have this number with a unit hanging out there without any explanation, there's a lot of variables here, so you have to explain which one this one is and this. And even though it's right here, rewrite it. The partial pressure of methane is equal to 53.6. Okay? So that is number 8. Okay, so now I want you to read problem number 9. And when you look at that, so hit the pause and go and read the problem and see how this one's different. Okay, so hopefully you got a chance to take a peek at that one, and you will notice that problem number 9 has sounds like it might be a Boyle's law problem, but yet they're bringing temperature into the thing, and they talk about collecting over water. So it gets a little bit overwhelming for when you first read it, because you got all these steps, and that's why I'm going to walk you through number 9 so that you can do problem 10 on your own. Okay, so let's go ahead and look at this sheet right here. What I want you to do is write all this stuff out so then I can explain it to you very clearly. So you're going to want this all written out, because remember, your notes are going to have all these problems in them anyway. There is one thing I want you to change. I don't know happened, why I wrote purple sheet. Who knows why I do some of the things I do. So that is a blue sheet. I am colorblind. In my defense, I might have looked at it and said the purple sheet, but it doesn't mean I'm color writing blind. I should be able to write the right word. So, but that is your blue sheet, and of course that's the thing that we used before. But we'll explain all this. But when you write it, put blue in there to avoid confusion of you looking for a sheet that doesn't exist in your reference packet. So hit that pause and get all of that written out. You didn't pause? Do it. All right. Good. Everybody back? Okay? Everybody has all this written down, right? Because I want you to listen very carefully so that you can do these problems moving forward. Okay, so the first thing, the words water displacement got me into this mode right here, which is to say, well, I know I'm looking for oxygen, and I want to know what the new volume of the oxygen is, but when I collected the oxygen initially, which of course is the one on the left, the initial pressure, it was collected over water. And remember, water is always kind of that little impurity that we just sort of have to fix. And that's why I said fix P1. You're going to do the same thing on problem number 10. You're going to get that first pressure. You're going to have to fix it. And then problem 10, all of them convert into standard pressure. So, but you gotta get that thing fixed first. And you fix it by, first of all, writing out Dalton's law. So that's Dalton's law of partial pressure. And that's the total pressure given in there. And a lot of people will plug that in right down there as your P1, but it's not the right pressure. It's a little bit wrong. And that's why we have to fix it. So we're looking for the partial pressure of oxygen is really what needs to go into that equation. So again, this 2.98 came from the blue sheet, not purple, blue sheet. And you look up at 24 degrees and you go across, it's got millimeters of mercury. Don't use that one because this is a kilopascal problem. So use the one where it's kilopascals, and you got 2.98. All right. So now you're going to be doing just a little subtraction problem here. Punch the whole number into your calculator. Don't go, well, I'm going to change this to 1 to the right because that. Just the only time you have to do sig figs is at the very end when you're translating for your stupid calculator. So what you do on this one is you say 98.5 minus 2.98 equals. Now, it's not gonna, let me go ahead and do that. So you got 98.5 minus 2.98 equals. And your stupid calculator says the answer is 95.52. And unfortunately, that is the wrong answer in terms of sig figs. So all of these problems, just like I've done on stoichiometry and the mole test, there's always that 1 point for getting the sig figs right. Now remember, we're adding and subtracting, so it's about place value. This, the people who did the partial pressures of water had a very accurate way of doing that, and they went 2 places to the right. The barometer checking the pressure for that day, or maybe somebody just looked it up on their phone, which is what we're going to do when we do our lab. Then you just write it down as given, but that's only 1 place to the right. So this is a better piece of data than that one, but a chain is only as strong as its weakest link. So since this has 1 place to the right, that's 2 places to the right. Your answer can have 1 place to the right. So when my calculator says 95.52, it's not right. Okay? the answer is 95.5, and you just drop that 2 off. So, and that's kPa. Partial pressure of oxygen equals this. Now, I'm going to treat this as a completely separate problem, like on the test. So you have to do, okay, because this is a Dalton's law problem, and this down here is a Boyle's law problem. So at this point, we have fixed P1. And then you can go and write down here in blue, P1, V1 equals P2, V2. Okay, did a whole nice, beautiful worksheet on that on the template. P1 is going to be your corrected pressure, and you're going to have to apply this in lab when we do it, because that's how we're going to collect the butane gas is over water. And so all we got to do is take the temperature of the water, do some calculations, and we can fix the pressure. All right, so this is the initial volume, and they want to know what the new volume is. So this is very similar to problem number 10. And you get to practice this 4 times on your own, little twists in there, but keep working those problems until you get the right answer. Remember, there is an answer key for all of these. Number 9, it says the answer is 75.3 centimeters cubed. All right? So V2 equals 75.3 centimeters cubed. Now, each one of these problems is actually, I kind of use the 1, 2, 3 method for grading these. That's a point, that's 2 points, and then number, units, and sig figs. And usually I actually give 2 points for the correct answer, so I kind of double that part up. But you can think of it as each one of these steps gets points. And one of the things I'd like you to do, just to kind of help clean things up a little bit, put a nice little box around the final answers for each one. And this is actually, like I said, 2 problems, so you might as well multiply that out and treat that as if this question was asking 2 problems in terms of the point value. Okay, so combination, Dalton's law, and Boyle's law, which are the 2 laws that we've done. So really work on problem 10. Okay. Don't just get frustrated when you punch in the number and it doesn't match that answer. Take another look back at number 9 here. You've got really good notes on it, hopefully explained everything. But make sure that you get all 4 of those. I believe, I don't have the worksheet in front of me right now, but you got like A, B, C, D, I think. But make sure that you get the correct answer. And I'm 99% sure that these answers are correct. We have used these worksheets over several years, so I think we would have caught a mistake. Actually, I haven't used them in about 5 years, but definitely this is those answers are right. Okay, and if you're gonna lose some sleep over it, shoot me an email. Maybe I can help you get on the right track. But I really want you to not just type it in once and go, I missed A, I'm done, forget this. This is what you have class time today to do. You're getting credit for having this stuff up on the computer on GoGuardian, but you got to make sure that you get number 10 right, and that you hash out and get the final answer correct. All right. So happy Wednesday, and no need to submit number 10. Just make sure you know how to do them, and you'll get credit today for being on GoGuardian. Just automatically, they'll be in the grade book by tonight, on Wednesday night. All right, take care.